Lesson 18 from Module 1 has us figure out how we can use ratios and rates to model 5 miles per 2 hours as the rate of 2.5 miles per hour. In this lesson, you'll also be able to interpret a rate as a division of two quantities or a fraction. You will also be able to multiply a rate by a quantity to solve a word problem. We don't have any new vocabulary words this lesson, so we're going to go straight into your example. Your first example, I have 3 different ways that you're going to be able to solve our given problems. So we have 5 gallons per minute over 10 minutes. The way we would demonstrate this in a fraction form would be 5 gallons, just in case this isn't dark enough, would be 5 gallons per, remember the fraction line means per, and that is minute, M-I-N, times 15 minutes, or 10 minutes, sorry, over 1. And just remember, whole numbers are always over 1. And all we do is go straight across. So a 5 times 10 is 50. Our minutes cancel each other out. 1 times 1 is 1, which leaves us with 50 gallons as the answer. That is your equation way of writing it. Down below we have a ratio table. So we have a 5 gallons to 1 minute. This is a ratio right here. It's also a rate. So 5 gallons to 1 minute. They want us to know in 10 minutes. So you write a 10. You take 10 divided by 1 to get your multiple, which is a 10. 10 times 5 gave me 50. Therefore, it's 50 gallons in 10 minutes. Your tape diagram, again, the ratio of 5 to 1. So we have 5 boxes and 1 box. And it says 10 minutes, so I set my minutes equal to 10. It's only 1 box, so all the boxes would have 10 in them, which would be 10, 20, 30, 40, 50 gallons. All 3 ways giving you gallons. Make sure you use one of these 3 ways in your bookwork in order to receive full credit. Down below we have a word problem that will continue on the back side, the solving portion. But the problem is the Piney Creek Swim Club is preparing for the opening day of the summer season. The pool holds 22,410 gallons of water, and water is being pumped in at 540 gallons per hour. Right there is your ratio, 540 gallons in 1 hour. The first practice is in 42 hours. Will the pool be full in time? And then explain. So anytime you have a rate, remember this also is giving you your ratio per 1. So 540 to 1 gallons to hours. The solving of this problem is here on the back. So starting up here at the top. Over here we have, at the very top, I've written out the pieces of information that we need. So we have 540 gallons per hour, which is important information. And we have 42 hours until practice. So these are the key pieces in the word problem that we need. Our ratio given this is 540 gallons to 1 hour, or 540 to 1. They are saying that the pool needs 22,410 gallons to be ready for the competition. Now, like I told you yesterday, there are several ways that we can solve this. So here is our ratio table. We have gallons to hours. We put 540 to 1. They gave me 42 hours, so I take my 42 hours, put it on my hours column. Right here, it's under the 1. I take 42 divided by 1 to get my multiple, which is 42. So I take 42 times 540, and that is 22,680. Over here is the work. 42 divided by 1 is 42. 42 times 540 is 22,680. So given this work, I'm able to say the pool will be ready because in 42 hours there will be 22,680 gallons of water, which is 270 gallons more than they needed. Now, the reason I did not do a tape diagram is because my ratio is far too big, so I can't make 540 boxes, so I chose to do my ratio table. You also could have done an equation. So down here it is the equation. You have 540 gallons per hour written like a fraction. times what we need, 42 hours over a 1, so they're both fractions. In order to do this correctly, your unit measurements have to be opposite of each other. So if you have two different ones that are hours, so we have a 1 hour and a 42 hours, we have them opposite sides so that their unit of measurement cancels out and all we have left is the gallons. So I then do 1 times 1 gives me a 1, which means my answer will be a whole number. 540 times 42 gives me the 22,680 gallons, which is the same answer from above. Therefore, our answer would be the same.